So in this problem, I'm presented with a piecewise function, and I'm told to find a value for a right there so that the function is going to be continuous. Well, there are a couple things that I know from the way this problem is set up. One is I know that it's possible to make this function continuous. Otherwise, they wouldn't have given me the problem like this. They would have said, oh, if it's possible, find the value a to make it continuous. But they said that I can make it continuous. The other thing that I know here is that if I look at these two pieces separately, 4 minus x squared, well, that's going to be a parabola. There should be nothing in that function graph that would make it discontinuous, except for the fact that it's stopping where x is less than -1. And similarly, this function here is going to be a parabola. I'm not exactly sure how it looks. It's going to be continuous, and that function is starting at -1 and getting higher. So if I'm going to have a point of discontinuity, it's going to be right here at -1. That's the only place it could possibly be, because by themselves, these functions are both continuous. So first I'm going to look at the function that doesn't have the a, and let's see what kind of information I have. So I want to find out what is the limit as x approaches -1 from the negative side, because that's saying that x is less than -1, of the function 4 minus x squared. Well, I know it's a continuous function, so I can substitute in -1 here. So I'm going to have, the limit is going to be 4 minus -1 squared. 4 minus 1, it's going to be 3. So as this function here, as this function here gets really close to x equaling -1, my y value is going to get really close to 3. That is my limit. So let's write it here, is equal to 3. Well, in order for a function to be continuous, the limit as x approaches c of f of x has to be equal to f of c. That's what's going to make it continuous. So I already know that the limit of this bottom half as x approaches -1 from the positive side also has to be 3. Because in our definition of limits, this is a limit as x approaches c. And remember, if I have a limit as it's approaching c, it has to cover c from the positive side and c from the negative side, if it's going to be a limit without qualifying it with the positive and negative. So I know that the limit of ax squared minus 1, let's go, limit of ax squared minus 1 as x approaches -1 from the positive side has to be equal to 3. All right, well, what is the limit of ax squared minus 1? It's going to be, as we're getting close to -1, it's going to be a times -1 squared minus 1 equals 3. So I have a minus 1 equals 3. A is going to equal 4. Let's just graph it and see if it works. So I'm going to have 4 minus, whoops, wait a second here, parentheses, 4 minus x squared, close parentheses. Now, that is for x less than -1. So I'm going to divide this by parentheses, x, second test, less than is 5, -1, close parentheses. Let's just see what that one looks like. I'm going to go zoom 6. So here's the graph, and it stops right there at -1, just like we had anticipated. And now I'm going to graph the other piece of it. I'm going to go y equals. Now we had said that a is going to be 4 if it's going to be continuous. So I'm going to go parentheses 4 x squared minus 1, close parentheses, divided by parentheses, x, second test, greater than or equal to, that's 4, minus 1. Zoom 6. There's my first piece. There's my second piece. It looks to me as if they're continuous. I mean, it's kind of hard with TI. TI is kind of a funky thing. But if I evaluate that function at x equals -1, second calc value, x equals -1, oh, I get undefined. Why is that? I know why that is. It's because it's two functions. And it was evaluating the top function here at -1. But if I go, if I click down here and I use the second function, I can see that y equals 3. So a little bit convoluted on the calculator usage there, but I think you get the idea of how to do this kind of a problem.